let's start with something really simple. We're gonna go and start extracting information from Revit because we want to read it. So for reading properties, we have this library that is called Revit. On Revit, we will find how to get selection and how to get extraction of elements. So if we go for selection, our first tabs are all elements of category. That can pick any category. We can also do it for levels, for family type, or types. But we're going to be using all the walls. Or the idea would be to get the walls. Within the walls, find the lines. With the lines, get the intersections, and then from there, create the structural elements that we will be using on our file. So I'm going to ask for the categories. The categories are going to be pulled from all the categories we have on the model. So if we jump for walls, we have wall tags, walls, hidden lines. We can also get properties, part of the property from the element. So if we're looking for a specific, we can change that. Now that it's full, we will find something that is called a list. The list is telling me in the order that we're model all the walls that we find. But that does not mean that they're going from down up. They can actually be in different ways. So let me show you a little about that. We look at the walls. So let's set the transparency to be 50%. And we could use Dynamo to see how the project was modeled. So let's see, we have these walls on this order. We have one option that it's called the generic override colors in view by groups and elements list. So we can use this for the walls and the elements inside of our project. So if we look at this, it may see the colors going from red up until they get blue. So most of them are following this pattern. I mean, this is the way it was created. So in the case you wondered how the project was being checked, you can also see that. If we look for other type of category, let's say we're looking for the floors, not the common edges, but the floors itself. You can pick properties as well. Yeah, I think we're looking at the ceilings. So we need to change ceilings for floors. And you can see, let me get the walls off. You can see how they were actually created. They were started from this one, going from here, 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 and then going up. So let's continue with our process of building construction. I'm going to leave the floors and the walls as something we want to read. So within that, we can see here that we have the element itself. The element itself will have some things inside it. So we can check what's the element holding if we go for the Revit elements. And Revit elements, we will find how to get properties or create properties from something inside of it. So if we go to element, we will find the basic properties we can check. So in this case, we can ask for a geometry. So just be careful about the geometry because once you pick it, what it will pull is will pull all the elements you have actually having on the project. So shall we do it? Yeah, it's already done. And as you can see now, the complete walls have been taken to Dynamo. Important fact that we haven't checked is that units require that the units you're using are actually, this is meters, and the units Dynamo is going to be using as a length. So length is really valuable because of that specific. So if I want to hide the geometry, I don't want it to be charged. Remember, each time you're calling a node, you're asking for all those transactions to be working. So you can also look at the location, which will give us much more value, since the location is just going to pull the lines that we have on the walls. So we want to find the points in which we need to place columns, structural columns, and to know how big they need to be. So what we're going to do for this is we need to separate them. So we can know that they are on a specific level and how good they are behaving. So we can move for the elements. We also have elements get parameter value by name. The get parameter value by name works if we use another that it's called parameters. So if you select an element parameters, it will give you all the information that you're using for. You have the image, the families, the uses, the data that you're holding from here. Also, if you want to see the type specific properties, you can call just by double click on the screen the type for an element, and then the parameters now they are type parameters. So you can call any of those. Specifically on this project, what we want to have is to know in which level they are being placed. So for the construction of a wall, we have one that is called base constraint. If we write it exactly like that base constraint, what it will do is now it's putting the levels of where the files are. So this is important because we want to separate that they are not follow on this on different. We're not mixing. We're having order in the way we're reading the information we want to get. So we have now the levels. We can also use the levels to check that everything is in shape. I mean, in this case, the colors are changing one by one, but if we want to have a clear separation of colors, we can also use it by levels. So next step I'm gonna do is we need to separate the levels with the walls. We have two lists of 72 elements because each element is giving me the values they're holding. And for doing that, we need to look a little on list management. We're having this type of lists that are only having one level, that it's the list and the elements inside of it. And if we look on the modifier, we'll have things to modify the elements. We have one that is unorganized called group by key. The group by key will find unique values and will find different types of elements. So if we look for keys, then we'll look for elements. Now it's going to be creating double lists, one that is holding all the walls for a single level, and at the end we have the levels named as a unique list. So if we have something like this and we change it, probably it will be mostly the same, but they are now just all the elements with the same type of color. So we have them separated by color. We want to sort it out so it can create the elements, and with that define our grading system of how they will work. So we want to get the grid lines on the elements where they are getting intersected. We just need to be careful about this one, because if the elements are not actually being created one by one on a single level, we will need to find a way to sort them out. So what I'm going to do, this is a basic process of checking that the elements are in shape. So we're looking at the levels. We go for the unique keys. The level of elevation is telling me they're going from 0, 4, 8, 12, 16, and 20. Because that's the only levels that are being used on this project. What I want to check is that they are actually sorted out. So it's not on inspect, it's on file. Yeah, modify file. Organize sort, yes. So if we sort it out and they were on a different position, what will happen is that it will go on the number base setting. So once I have them sorted out, I need to fix that the walls are actually in place with that same list property. So what I'm going to use is the one function that it's called the match require inspect called index of. That function index of is going to find me where these values are on this list. In this case, they are sorted out, but if a case is not, but you don't have it sorted out, they will be on different locations. So when it's wrong, it will give me the actual location I want to find them. Then within the list, we can get the item list, get item index. I think that one somewhere is it's as well on a match charts. Item index on inspect. So I'm having here an index, the number where they are being applied. If we collect from the unique keys, it will give me the levels sorted out. This is just in case that the levels aren't sorted out, or they will create a different logic. And the groups sorted out as well. So we create different groups for elements. So for getting the grid lines and points of creation, we're going to use a function for practical being that is called intersection points by lines. And what I will do is that we check it. Yeah, we're not asking here for the walls. We need to use the lines we have created. So check this one. Yeah, changing it for lines. Now it's creating all the intersection points that we have. You can see here how the elements are just having the points where the lines and the grids are intersecting, and that will help us to create specific framings from all those lists. So it's giving me the points. It's having that same structure. If we want to have, generic color override is no longer available because it's not changing colors on elements. So I'm just gonna copy this one. If you're not seeing copying, would be easier if you just select the node, just press Ctrl and drag it down. And in that case, now it's following the path. If we look on our model, it's just the walls being separated like that. And we can check. So we're having intersect point by lines. That means that we're having the points of the grid being placed. If we want to use the function intersect points by all grid lines, what it will happen is now it's giving me also the points are getting on all the grids. So that means that they're creating a structure that is combined, but the actual location points are being added. So it's creating a grid system that will follow all the lines of the walls we have, and that will make it smaller spans for these slabs. So we will need both because they have different components. So let's see how those are actually working. So in the case we have the point list of these elements, we can look for the beam lines. So we have a function that is called beam lines. By point collections X and Y. This is going to be really useful because if we click it, now I just need to turn off my lines, my locations. And the result is actually giving me the complete lines if I'm using the other grids. So it knows where all the surfaces being created. So if I want to get columns of all the elements, it will complete the walls. And within that, this is going to help us to get the surface properly and to know where is the regularities of all the elements being placed. It's actually dividing the spans for the floors to be created. And within that, we already have a system that can give us the framings we want. If we use it for the other function, turn this one off, we're actually having the complete framings just relying on the walls we're using. So we can have framings separated by those intersections, or we can have framings of all the systems, and we can have columns on all intersections on just the systems we're using. So we will check both options to see how the final result goes from there. So let's keep on creating the lines we're going to be using, and in this case, next step will be to get the levels of the elements so they can have columns. Inside of it, we can use any of the two protocols. We're going to use both, so we can check the difference between those. So first component we're going to get is the level elevation. The level elevation from the levels will be extracted from the walls we have. So that means that if it's a wall, it will create a line down and up, and it will continue closing the element. So we're having the level elevation. Then we have a function that it's called get higher level from level with height. With that one, we can select the level. The level is going to be full, and we have the height values that they're going to be performing. So if we do something like this, a minus b, what we want is that the higher value is going lower. We need the distances we need to check for any of those. And with those distances, we want to create vectors. A vector, if you're familiar with it, it's just a distance that is going to be moving. So we want them to move vertically on each of the levels we're getting. Actual coordinate, we need to go x and y is 0. And with those components, what we can do is go for the geometry to be translated just by direction. So a vector is moving the points list we're using to a different level. So we're having something like this. That's if we're using just the intersections of the element. So if we already have the geometry translate and the points list, we can get a line that's going to become our columns, and it's going from the points list to the geometry list. And that's actually creating a grid structure that it's holding the elements inside of it. Then, if we're missing the roof, you can go for a last item. Last item, which is the last setting of the geometry we're using. And with that, we're gonna still use the beams from connector like that. So the only thing it's gonna do is if it has the points, it will create the grading system. So we have now the columns, we have now the beams, we have now the points collection. So we just need to be careful on the way we're using them, because they have a specific structure for creating things inside of it. So for the floor creation, we need to use the beams, but not actually just the beams we're using the specifics, because if we do that, they won't work because they are too irregular. We need to use the all beams collection. So I'm gonna turn this one on and off. I'm gonna turn the lights off because they are getting too much inside of it. It's all the beats. I'm gonna move this one down. So I'm gonna turn off the last one. And we can use this to create the surfaces we needed for creating floors. So our first step is gonna be by using the line. It's called create surfaces by creation lines. It's actually using the X lines and Y lines to be connected. It needs to be a shortest method of lacing, so that way we only have the exact number of surfaces being created by each one of those. So we have the lines paired and the surfaces being created. So we can know the lines on Y from the 18 and the lines for Y for the 17. Yeah, for any of the surfaces we have it. So with this, we already have a surface creation method. You need to mix out with the real location we have on the elements. So let's keep on creating the elements so we can see them. Okay, so let's start creating some structural elements. We'll start with the columns because the columns will give logic to the elements, and then when we connect the framings, they will respond to that. So we're going to go for the structural columns to see if we have the families we require to use it. So far we're using the universal column. We will load the family, a concrete column family. Within the library is going to English structural columns, concrete, rectangular, the basic column just to be placed. And it's going to be vertical. I'm just going to skip. I'm going back to need to find out where I have my columns. Those needs to be my columns. So we can go for the Revit elements, structural framing column by curve. So if we use the curves, we can use the levels. So that's what we picked from here. And we're missing the structural column types. So far we're gonna start with the basic creation of elements just by using the structural type basic 300 by 450. We will need to modify that. And remember, in this case, to be shown up, we need to connect structural columns. Structural framing will be requiring that first are already set. So we can see how the columns are responding to the intersects of the walls. They are just creating the elements there. So it will depend on which is the locations we have. So we can set difference in the way structural columns are being placed. But so far they are depending on the height the elements and the walls require. Next step, we're gonna set this one, set the other one, and let's go now for the structural framings. Look for columns, framing types, we're gonna be using them. So in the case of the elements, we see a complete grid, but we need to look at just basically something like this. So what is gonna happen is we're gonna go for the Revit element. It's structural framing in by curve, using the curves, framings, and in the case of the level, we need to have the last item as well in this case because that's the top. So if it runs, she'll create the lines on the top. You can see here that we have the framings on one direction. If we change orientation just to have both, they should have now these construction settings of the framings. So same process, we want to extend that going down to all the other levels. So what I'm gonna do is just gonna pick the same, copy, just drag it down, and we need to construct that. Just gonna turn off this one, turn on, turn off, and then we have the same type of structure. It's using just the lines below the walls. So we'll go orientation on curve, orientation on curve. And the levels list needs to be complete levels list because they need to go both ways. So let's create. Under result is something like this. It's creating just basic component elements from that. So we can see how the grid is being placed. We already have the floors being created. So we need to adjust those so they are actually fitting the spots we wanted. And we need to add circumstances in which the sizes of the family is going to be changing, because we know that if it's smaller, size can be smaller, bigger, and getting all of those working around together. So our next step will be to create the structural floors. We already have a reference because there are some floors being created, so they give us the idea of where they need to be placed. But remember that these floors have been placed through the wall settings. So we actually need that these lines are inside of the axis, so that if the floor is created, it's already used within the same elements. If we're using different type of structural methods, we also need to get the framings a little lower, and then the floor going up, getting the subtraction of the column. So let's see how that process needs to go. So we're gonna go for Dynamo, and on Dynamo we really have taken the floors, define all the elements of category. So we want to know whereabouts they are. We need to do something similar. That's what we have done with the walls. And we're going to use the function floor outline curves from bracket in. In this case, if they don't have any points inside, it will be helpful. If they have it, we need to make different type of approach. But so far, I will go removed off the floor we have already created. So in this case, before doing that, just remember to disconnect the curve creation, because if we do so, we'll be creating again new curves. We have already closed the function. If it's our first time and we haven't, it would remain with the same things. So what I'm going to do is, now that I have the floors, you see here the floor outlines, I'm also going to hide the other elements because we want to have clearness of what I'm doing. Preview, it will preview. Right? So I'm going to go with the outline curves. You can see how we have a difference here because they are going through the wall settings. These floors are actually in the middle of that. So we need to decompose those. So we have a function that is called point curve. Find general curves. We're going to get a surface. A patch. And in that case, we also need to separate to which level they are belonging. So we need to have the same parameter value. So we're actually creating surfaces from the outline curves, and we're also reviewing its get parameters. Parameter length is equal to level. So it's being picked. So really creating the levels and the surface patches. So we're gonna do a flatten because the surfaces are inside the list. And we want to sort it out just by grouping. So we're going to use a group function. Group penalty using the list of elements and the keys that we want to hold. Yeah, you need to be careful about the levels are on the proper sorting group. If they aren't, we just need to get the elevations so we can know whereabouts they are working. Level elevation is sort. So the elevation is being sorted out like that. Index of and I can eat them as index. So that these elements will have now their own settings. And you can know this is called level elevation because we're getting the elevation, not creating from the elevation level. That's it. We're getting the list. Now the levels are the surfaces have already been sorted out properly. So what else is missing? We need to know how these ones are getting intersected and to which types of frames they are working, because otherwise we cannot get that in-between points that we're looking for. So we need to go to the intersection. We have line or grids. We have the beams. We have here the create surfaces. So with this surface creation, we're going to use it to get to the proper elements. So our next use is going to be called group surfaces and join by intersection with floors. Really specific. We have the pull-up surfaces. We have the surfaces that we already wanted. We call it. That's going to create the set of surfaces. But the problem with these ones is, as you can see, we have poly surfaces and surfaces being together. So if we want to use them for creating a floor, it's not going to work because we have the same type of perimeter surfaces. We can check that. It says perimeter curves being placed. It runs. Now we have the lines inside. But the number of curves there are too much for just regular element lines. So we're going to use a function that is called group multiple lines by parallel intersection. And a function that is called simplify parallel align group of curves. If we do it so, now our result is doing the grouping of types of lines to solve the polycurve problem. Now it's just becoming the basic curves for each type of parameter of surface, and then you can do a polycurve by joined curves, polycurve by joined curves. So if the lines are getting together, creating just basic polycurves, the polycurve can go now for the through outline by outline. Type and level. The polycurve is getting the outlines and outline curves. It's actually just the outline we're using. We need to use this function because we wanted the lines to be on the proper location. doing the curve properly, and sorting out how the file will get. And then if you go floor, and if you can otherwise, we'll use the conjugate 200. And for the levels, we just need to get back to replace our levels. This is the levels we want to use. So each row will have their own levels. So just because of the way they are in place, if we place it on the level, they will go on the lower part. We just need to give them the proper height. So we're gonna use the set parameter by name function to get the element with the parameter height offset from level. And the value will be 0. So we will run it. Alex, let's misspell the HT. Just need to be careful because it's creating the floors on the same location, and now we got our structural floors that are actually in the middle of the building. So if we check our analytical one, they will fill the spot we wanted to have. So we can also have the last set of polycurves. So we're going to have a last item. That last item we want to have the proper leveling. So we're gonna pick the last item as well. Here we can have a high now. It's higher level for another height. So we're having the level value, elevation. So we know which is the elevation we wanted to move. Then A minus B. Translate the vector of height Z. So the geometry can be put up. Then you can use the front outline the same way, using the level value, same floor height, and then the height as well. So I'm gonna go Control C before we have them. Then go into the construction and create one again. Now, just go Control C. Just The ratio giving me a vector is working fine. So but this one is the last item is just giving the last polycurves. So we're missing here cross product and I think that will do it. So going Control Z. Change the brother. Longest. Yes. You know we have it. Just now go to the back, checking that there's only one element, and run it to the function it's completed. Yeah. So now we have drawn the final draw the settings. You can notice that it's not creating the floor in the gaps because there isn't any floor there to create. So with that, we can check that we have our analytical model and we can use it for other purposes.